Welcome to our sixth and last video in the explainer series, looking at how the rules of exponents work the way they do, or why they work the way they do. The last rule we're looking at is that a to the power of 1 over n is equal to the nth root of a. Right, so the way that we can see why this works is if we are to say a to the power of 1 over 2 times a to the power of 1 over 2, we know using our first rule, the rule of multiplication, that if we have two powers that have the same base, we can just add their exponents if we're timesing them. So we have a to the half plus a half, which is equal to a to the 1, or just a. But wait a minute, what are two things? Well, what is a expression that I can times with itself to get a? That sounds a bit like the square root, right? A is also the same as the square root of a times the square root of a, right? Or 9 is the same as the square root of 9 times the square root of 9, etc. We can do this for even other fractions, right? So if we have a to the power of a third, if we times it with another a to the third and another a to the third, right, we get a to the third plus a third plus a third, and 3/3 gives us 1. But that is also the same as the cube root of a times by itself 3 times, right? So we get this idea that a to the half should be the same as the square root of a, or a to the third should be the same as the cube root of a, and so on. And from there, it's not too hard to arrive at the more general idea that a to the power of m over n is equal to the nth root of a to the m. So for this one, we can just say a to the m over n, right, is the same as a to the m to the power of 1 over n, right? Because we know that if we have a to the b raised to the c, it's just the same as a to the b times c. From the previous slide, we saw that something to the power of 1 over n is just the same as that something, the nth root of it. So this is then the same as the nth root of a to the m.